Let's talk about solubility rules. Now, a couple caveats. First, when we say soluble, we are referring to solubility in water only. We're not referring to solubility in other solvents like ammonia, ethanol, methanol, isopropanol. We only concern ourselves with water in these courses. Second, there are actually several metals that will form hydroxides with water and immediately precipitate out. You're not required to know these. Just assume that if something meets a solubility rule or an insolubility rule, you're not going to worry about side reactions with water. Now, in addition, we've got two rules here. The first are going to be the solubility rules. And the solubility rules are going to tell us how we can dry something into solution. So if we've got something bound to our ion of interest, we know it's soluble. The second set are the insolubility rules, and these are compounds that are generally insoluble in water. Now, the solubility rules are going to trump the insolubility rules. So if we've got something like sodium, which we know is always soluble, bound to something like phosphate, which generally isn't, the solubility rule is going to beat out the insolubility rule. So let's talk about the solubility rules first. There's two types of ions we use to deliver, that we want to deliver solution. So the first are going to be anions, things with negative charges. So if we want to deliver something with a negative charge, we've got two things we can use. First is ammonium, NH4+. There are no exceptions to this. If something is bound to ammonium, it's going to dissolve in water. The second are the column 1 elements excluding hydrogen. So lithium, sodium, potassium, rubidium, and cesium. These elements, whatever they're bound to, will dissolve in water. So if you have something like sodium chloride or sodium hypochlorite, NaClO, all those are soluble in water. Let's say we want to deliver cations though. We'll have a cation delivery vessel. In this case, we've got less options to go with. There are three that are always soluble. Nitrate, NO3-1, acetate, C2H3O2-1, and chlorate, Cl3-1. If we have those anions bound to a positive ion like chromium +2 or manganese +3, that's going to dry them into solution. There are a few others though, but they do have exceptions associated with them. So one is the halogens excluding fluorine and acetone. So chlorine, bromine, and iodine. These are generally soluble. So if you have something bound to chlorine, bromine, or iodine, generally it's going to go to solution. There are three exceptions to this though: silver, mercury, and lead. Another anion we can use to deliver a positive charge is sulfate, SO4-2. Now there are some big exceptions to sulfate as well. In addition to the silver, mercury, and lead we had for the halogens, we're going to have to add three others. And these are calcium, barium, and strontium. Calcium sulfate, strontium sulfate, and barium sulfate are all insoluble in water. So that's it for our solubility rules. What about our insolubility rules? If we have something bound to carbonate, phosphate, chromate, CrO4-2, and sulfide, S-2, these are generally insoluble in water. The only exceptions being ammonium and the column 1 elements. If those are bound to these particular polyatomic ions, they're going to be soluble in water. The other one are hydroxides, OH-. Now again, generally if you're bound to ammonium or you're bound to the column 1 elements, lithium, sodium, potassium, rubidium, cesium, that'll be dissolved in water, but anything else bound to OH is going to be insoluble. So vanadium hydroxide is insoluble, calcium hydroxide is insoluble, and strontium hydroxide is insoluble.